Okay, I think we can start now. Hello everyone, welcome to IITN's GATE classes. My name is Mithilesh and today we are going to solve GATE 2026 Aerospace Engineering um, exam paper, and we will be focusing on engineering mathematics in this session. So let's understand first of all the number of questions which were asked in this paper. So overall, there were 7 questions from engineering mathematics. 4 questions were for 1 mark, and 3 questions were there for 2 marks. And in total, 10 marks were for mathematics. If as we go on, you will see the weightage, but in general, the 3 questions in this paper were from linear algebra. 1 question from calculus, 1 from vector calculus, 1 from Fourier series, and 1 from the differential equations. So this is how the split was. Let's now start solving these questions one by one. Okay, we'll first solve the 1 mark questions and then we'll go to the 2 mark questions. So this is a 1 mark question. It's from the vector calculus. So question is, consider the contour C. Look at the figure as shown in this figure. For the vector f bar, which is x plus 2y, you can consider this as I, 2x plus 4y j. The integral f bar dot dl bar, or you can also consider it as f bar dot dr bar, is equal to, okay, because this dl bar represents infinitesim's length along the contour C. So let's try to answer or solve this question. This is from the integration over a closed curve C. So let me go to the next slide and we will solve it. Yeah, the correct answer for this question is option A, and let's see how we get it. There is a Green's theorem. You might have heard Green's theorem. This problem can be solved by Green's theorem. What Green's theorem says: integration over a closed curve C, m dx plus n dy is equal to double integration over the region R, differentiation of n with respect to x minus differentiation of m with respect to y. Okay, this is the Green's theorem. So this Green's theorem is used to convert the integration over a closed curve into the region integral. And this we can clearly see, this is integration over a closed curve, and we can convert this into a region integral by using the Green's theorem. However, the format is slightly different. This is m dx plus n dy, but this format you can easily get, which is this is your m, because when you put it into here and take a dot product with a dl bar, which is dx plus I dy, right? And you will directly get this will be your m dx and this will be your n dy. Okay, so we can clearly use this. So what is the value of m? As I said, the value of m is x plus 2y, and the value of n is 2x plus 4y. Okay, differentiation of m with respect to y is what? 2, right? Differentiation of m with respect to y is 2. Differentiation of n with respect to x is also 2. So we got both the derivatives as 2. So 2 minus 2 will become 0. So double integration over the region R is 0. Since our integrand is 0, the final answer is 0. Okay, so we can choose the option A here. Okay, for this question. Okay. Feel free to ask your questions. Let me proceed to the next slide, and we'll talk about the second question. This is again for a 1 mark. This question says the Fourier series representation of a square wave is shown in this figure. Okay, yeah, this is the square wave, and we are trying to represent this square wave into the Fourier series expansion. Okay, the fluctuations were seen. The fluctuations were seen near to plus or minus, sorry, near to +1 or -1. Okay, at both this +1 and -1 are named after which one of the following scientists? So yes, the option here is option C, which is Gibbs. So the fluctuations near the jump in square function, what we have is we have a jump like this, correct? So fluctuation which we can see near jump, this complete fluctuation here, this is a complete jump, right? So we have seen these fluctuations, right? These fluctuations near the jump at x is equal to +1 and -1 in the Fourier series approximation of a square wave is called as Gibbs phenomenon. So this fluctuation is nothing but the Gibbs phenomenon. Okay, and that's why and scientist Gibbs has shown or highlighted this phenomenon. That's why the option C is correct in this case. Yeah. Another question. This is again for 1 mark. This question is: we have a matrix A, which is n cross n. Okay, and that matrix satisfies this equation, that is A transpose is equal to A inverse. Then the determinant of this matrix may take which of the following values? Yeah. So this is a square matrix and A transpose is equal to A inverse is given. The determinant of this matrix may take which of the following values? What is this matrix? The matrix which satisfies A transpose is equal to A inverse. What does this mean? It means A into A transpose is equal to identity matrix, right? So this matrix is called as orthogonal matrix. Okay, so the matrix which they are talking about is orthogonal matrix because it is satisfying A transpose is equal to A inverse. Now the question is, determinant of this matrix may take which of the following values? So let's solve it. Since A transpose is equal to A inverse, we can say determinant of A transpose has to be equal to determinant of A inverse. Correct? What is determinant? We know that determinant of A transpose is equal to determinant of A. Okay, which is known to us. Even if we take a transpose, the determinant remains unchanged. We know that. So I can say this as, rather than let's write first. I'll write it in the next slide. Determinant of A transpose is equal to determinant of A inverse. And since I told you determinant of A transpose is what? Determinant of A. So determinant of A can be written as determinant of A inverse. You can also write determinant of A inverse as 1 upon determinant of, or let's write it as determinant of A equal to 1 upon determinant of A. Determinant of A inverse is equal to 1 upon determinant of A, right? So you can also write this determinant of A comes to this side. You can say determinant of A whole square is equal to 1. What does this mean? This means determinant of A has to be plus or minus 1. Either it can be +1 or -1. Considering this, we can say Option A and B are correct. So here they also mentioned in the question, this is multiple option type question, okay, or multiple solution question. So we have values, yes, they have mentioned, and this should highlight you that there could be multiple options. Okay, option A and B is correct for this question. Okay, so if you know this, if you are able to understand that this is orthogonal matrix, the problem is very, very easy to solve. So this was the first question from the linear algebra. This is the second question again from the linear algebra. If a matrix is written as A is equal to U into V transpose, where U and V are n-dimensional non-zero column vector, then rank of matrix A is. Okay, let's understand first what they have given. So what is given data? Given data is A is equal to U into V transpose. And what is U? U and V are n-dimensional non-zero column vector. So U is equal to, I would say, a column vector which is n-dimensional. So n cross 1. Okay. The size of U is n cross 1. Similarly, size of V is also n cross 1. Correct? Now, you are multiplying U, which is n cross 1, and you are multiplying V transpose, which is 1 cross n. Ultimately, you will get a n cross n matrix. So the matrix A is a n cross n matrix. I hope it is clear so far. But now let's look into the how exactly this matrix looks like. The question is, what is the rank of this matrix? Question is, what is the rank of the matrix? Okay, so let's try to simplify it. I will assume U as a vector, which is, let's say, U is what? U is a n cross 1 n cross 1 vector, which is, let's say, A, B, C, and D. Let's say 4 cross 1 in simple. Okay, let's assume n is equal to 4. You can also assume 3 or so. Then V can assume as E, F, G, H, because it is again, it has to be same. So V transpose will be equal to E, F, G, H, 1 cross 4. And now if you multiply U into V transpose, what you will end up with is, you will end up with is AE, AF, AG. So this I am multiplying U with a V transpose, and AH. Similarly, BE, BF, BG, and BH. CE, CF, CG, CH, DE, DF, DG, and DH. You can clearly see all the columns. If you see this first column, second column, all the columns are, or all the rows are linearly dependent. Okay, we can say every column is proportional. So you can these two columns are proportional. Similarly, these two columns are proportional. So every column is proportional, or every row is also proportional. Column is proportional. Okay, it means every column is linearly dependent, and it means what? You can make use of this column to make this column 0, or you can also make use of this row to make the another row 0. Okay, since all the rows and all the columns are proportional to each other, one row can be used to make all the rows 0, or one column can be used to make the rest of the columns as 0. Hence, only one row or only one column will be remained at the end after row or column operation. Hence, the rank of this matrix A is 1. Okay, so correct option for this question is 1. Why? Because all the rows or all the columns are proportional, they are linearly dependent, and if you perform row operation or the column operation, ultimately you will be end up with only one row or only one column. That's why the rank of only one row or only one non-zero, I will say non-zero row or non-zero column, and that's why the rank of this matrix is 1. Okay, I hope you are following it. Let me go to the next slide. You can also take any other example. I just took this particular case so that you can visualize this, how they are look at these numbers, like how they are proportional, but you can directly tell the answer at this moment itself that rows will be proportional and they are linearly dependent, and that's why rank is 1. Okay, you can also assume 2 cross 2, 3 cross 2 cross 1, and or 3 cross, for example, as well. Okay, let's go to the next slide. Another question we have. This question is for 2 marks. Consider a matrix again from the linear algebra. Okay, this is third question from linear algebra. We can see this time a lot of weightage has been given to linear algebra. Let's read this question first. For the matrix A, B, C, D, the relation A plus B is equal to C plus D holds. So for this matrix, they have clearly mentioned A plus B is equal to C plus D, and none of this element is 0. Then which of the following statements is false? Okay, so one statement is about the eigenvector, and rest of the 3 statements are about the eigenvalues. Okay, so this question is all about the eigenvalues and eigenvector. So if you are able to find what are the eigenvalues and eigenvector, we can easily solve the problem. So let's start with option 1. First option says this is eigenvector. Let's check whether it is an eigenvector or not. Okay, I'll solve this question here. When we say matrix A is there, X will be eigenvector if we are able to write it as lambda times X. Then X is eigenvector and lambda is eigenvalue. Okay, so A, B, C, and D is your matrix A, and what is X? X is 1 1. Correct. So let's do this multiplication. AX is equal to, let's see what we get, A plus B and then C plus D. However, they have given A plus B is equal to C plus D, so I can write it as A plus B times 1 1, or I can also write it as C plus D times 1 1. So what this indicates? It indicates that yes, I'm able to write this is satisfied. Ax is equal to lambda x, because ultimately you are getting x, right? So 1 1 is eigen vector, and this A plus B is eigenvalue, and A plus B is equal to C plus D. So A plus B is eigenvalue, then C plus D is also eigenvalue. Okay, so I hope you understood. We applied a simple logic that Ax is equal to lambda x. Matrix A multiplied by the eigenvector should give us the eigenvalue times that same eigenvector, and if that condition is satisfied, then that x is called as eigenvector corresponding to the eigenvalue lambda. And when we did that multiplication, we were able to take A plus B common, and again we got the 1 1, which is matrix X. So I can say that 1 1 is eigenvector, yes, and as we said, so this is a correct statement, and A plus B and C plus D are the eigenvalues. Okay, A plus B is eigenvalue, C plus D is also eigenvalue. C plus D option is not there. There are some other eigenvalues. D minus B. Okay, let's try to solve again. A plus B is equal to C plus D. Okay, yeah, we know that. Okay, there is one another rule we know is trace of a matrix. Trace of a matrix is equal to sum of eigenvalues. Eigenvalues. So lambda 1 plus lambda 2 is equal to trace of A, which is A plus D, right? Look at this. A plus D is a trace of a matrix. So now lambda 1 we calculated, which is A plus B. Yeah. Plus lambda 2 is equal to A plus D. Right? A gets cancelled. Lambda is equal to D minus B. This is lambda 2. Lambda 2 is equal to D minus B. Okay. So D minus B is also an eigenvalue. So this statement is also correct. So the only wrong, all false option is option D. So you should choose the option D here, because they are asking which of the following statement is false. So option D has to be chosen. Rest of the statements are A, B, C are option. These options are correct. Okay. So the false option, which is option D. Okay. So we have applied two things in this question. One is the basic property of the eigenvector Ax is equal to lambda x, and second one is trace of a matrix is equal to sum of eigenvalues. So this was the third problem from the linear algebra. Let's go to the next question. This question is from the differential equation. Let's go through it. Consider the differential equation with the initial condition given below. If y of x is the solution of this differential equation, the value of slope dy by dx at x is equal to ln of 2 is. Okay. So they have given this differential equation. You know, this is a higher order differential equation with a constant coefficient, and it's homogeneous because on the right hand side we have 0. Since it is a homogeneous differential equation, the solution of this differential equation is the complementary function CF. Okay, only. And they have also given the initial condition y of 0 is 0 and y dash of 0 is 0. Okay, y when x is equal to 0 is 0, dy by dx when x is equal to 0 is 0. You can also simply say it as y of 0 is 0 and y dash of 0 is 1. Y of 0 is 0 and y dash of 0 is 1. Okay, and the differential equation is the homogeneous higher order differential equation with a constant coefficient. Okay, so let's solve this. I will write this differential equation on the next slide. d2y by dx square plus 2 times dy by dx plus y equal to 0. D square plus 2d plus 1 operating on y equal to 0, you can say. And you can consider this as an algebraic equation, and which is d plus 1 whole square has to be equal to 0. It means d is equal to minus 1 comma minus 1. Yeah. So the solution is y is equal to c1 plus c2x into e to the power minus x. Okay. Y is equal to c1 plus c2x into e to the power minus x is the solution, because the roots are real and repeated. Okay, so that's why this x is coming into the picture. Otherwise, it's the c1 e to the power minus m, c1 e to the power m1 plus c2 e to the power m2. Okay, but here m1 and m2 is same, so c1 plus c2x e to the power minus m1. So m1 in this case is minus 1, so e to the power minus x we are writing. Okay, generally you know c1 plus c2x e to the power minus m1x. This is the general root when we have two roots which are m1 and m1, real and repeated. Okay, so we got the solution, but in this case we have two constants, C1 and C2 are the constants, and which we have to remove by what? We have to remove them by boundary initial condition which they have given. Okay, these are the conditions they have given. We can make use of these conditions to remove them. So let's dig into it. Y is equal to C1 plus C2x e to the power minus x. Okay, y of 0 is 0. So when x is equal to 0, y is 0. So this implies 0 is equal to C1. This, okay, 0 is equal to C1. So y is equal to C2x e to the power minus x. Take y dash. Y dash is equal to what? C2. Differentiation of x e to the power x is 1 minus x e to the power minus x. Okay. Y dash of 0 is 1. Another initial condition they have given is y dash of 0 equal to 1. This implies 1 is equal to C2 into 1 minus 0 e to the power minus 0. Okay, e to the power 0. So C2 is equal to 1. This implies y dash is equal to 1 minus x e to the power minus x. Okay, we got this. Now, or we can also write it as 1 minus x divided by e to the power x. What they are asking is y dash of ln of 2 when x is equal to ln of 2. Correct? When x is equal to ln of 2, what is dy by dx? Dy by dx means y dash. So y dash of ln of 2 is equal to 1 minus ln of 2 divided by e to the power ln of 2. So 1 minus ln of 2 divided by 2, which is 0.153. Okay, 0.153. So correct answer range was given this 0.151 to 0.155. Okay, and our answer is perfectly in that. 0.153 is the answer. Okay, we have another question. This is the last question from the mathematics. They have, and this is from the minima and maxima topic from the calculus. Let's go through this question first, and then we'll start solving it. The minimum value of the function f of x, which is equal to mod of x plus mod of 2x plus 3 for a real x is, okay, rounded off to 1 decimal place. So if you consider the range minus infinity plus infinity, this function will change the sign. Okay, so at x is equal to 0, first of all, because we know mod of x is what? Mod of x can be either plus x or minus x. The function you have to write either as plus x or minus x, right? Plus x you will consider for all the values from 0 to infinity, and mod of x you will consider as a minus x for all the values from minus infinity to 0, because whenever you put the value of x as minus of x and x value is minus, so then minus minus, let's say minus 2, minus minus become plus 2. Okay, minus x is the function value. When you put x is equal to minus 4, minus minus will become plus 4, right? Because ultimately mod function should give us the positive answer, and that is possible only when in this range you consider it as a minus 1 x, and in this range you consider it as a plus x. Correct? So 0 is the point at which sign of the function changes. Similarly, for this, at what point the sign of the function changes? Minus 3 by 2. Minus 3 by 2 comes somewhere here. Okay, when x is equal to minus 3 by 2, that is the point where the function value changes. Okay, so we got now 3 intervals. This is my first interval, second interval, and third interval. In all these three intervals, we have to check what is the minimum value, and that will be our answer. Okay. Let's start with this third interval. Third interval. It's quite simple. In this case, how can you write your function? It will be x plus 2x plus 3, correct? You can consider any value of x in this case. Let's say beyond 0, x is positive, so you can consider 1, 2, 3. As you increase the value of x, what will happen? Third interval, function is increasing, right? Function is increasing from 0 to infinity, right? So the minimum value will be at 0, correct? So minimum value will be at x is equal to 0. And what is the value? F of x is equal to 0 plus 0 plus 3. So hence 3 is the minimum value in this range. So in the third interval, the minimum value of the function is 3. As you put x is equal to 1, 2, 3, 4, 5, the value of the function will go on increasing. Yeah. So in this range, we found out. Now the second range, minus 3 to 0. Let's try to find the second range. Second interval is minus 3 by 2 to 0. F of x, what can you write? Mod of x plus mod of 2x plus 3. In this interval, what should be the value of mod of x? Mod of x has to be minus x, because whenever you put any other value, let's say any value of x, let's say minus 3 by 4, somewhere here, minus minus becomes plus. You want plus 3 by 4 as answer, right? So that's why you should consider minus x here. And plus 2x by 3, because in this interval, any value of x you put, you will ultimately get the positive answer when you put the value of x here. Yeah, from 0 to minus 3 by 2. So when you solve this, you will end up with x plus 3. And so minimum value is, and now you can see in this range, what will happen? Max, when you put x is equal to 0, f of 0 is 3. And when you put x is equal to minus 3 by 2, f of minus 3 by 2 is what? Minus 3 by 2 plus 3, which is again 3 by 2, which is 1.5. Correct? So minimum, so it's again the increasing function in the range minus 3 by 2 to 0. The function is increasing function with a minimum value of 1.5, and the maximum value will be 3. Okay, so it will increase from 1.5 to 3. I hope you are following. And then, so the minimum value in this range is minus 3 by 2 to 0 is 1.5. And now third interval. Okay, third interval is what? Minus infinity to minus 3 by 2. Okay, what is our function f of x? F of x is mod of x plus mod of 2x plus 3. We can write it as minus x minus 2x plus 3, which is minus 3x minus 3. And you can clearly see here, this function is decreasing function. Decreasing function. Okay, decreasing function means you will have maximum value here and it will go on reducing here like this. Because let's try with some bigger value, minus 100. If you put minus 100, what will happen? If you put minus 100, what will happen? Minus 3 into minus 100 is plus 300. Plus 300 minus 3 is 297. Put minus 200. Minus 200 into 3 is minus 600 minus 3 is 597. So as you go in the left hand side, function is increasing. So minus infinity to 3 by 2 is function is decreasing. Hence you will have minimum value at x is equal to minus 3 by 2. And what is the value? F of minus 3 by 2 is minus 3, minus 3 by 2, minus 3. So it will become 6. Sorry. Yeah. How much? 9 by 2, minus 3. Yeah. Let me check. Minus 3. Okay. Minus 3. Minus x into minus 2x is minus 3x. And plus 3 and minus will become minus 3. Yes. And when I put x is equal to minus 3 by 2. So minus 3 into minus 3 by 2. Minus 3. 339 by 2 minus 3. Okay. And yeah, if you solve this, what you will get is how much? 9 minus 6 by 2. Right? 3 by 2. Yes. So 3 by 2, and again it is 1.5. Yeah. So we got 1.5 in this range minus infinity to 3 by 2 at minus infinity to minus 3 by 2. Similarly, in minus 3 by 2 to 0, we got 1.5. And then in this range, we got 3. So in simple word, if you try to plot it, okay, let me give you a bigger picture. So in simple word, let's say minus infinity to minus 3 by 2, then 0, and then infinity. The function is decreasing to 1.5. Then it will become 3. And then maybe again it is increasing. So the minimum value is at minus 3 by 2, and it is 1.5. So correct answer in this case is 1.5. Okay, which we got. Okay, so you should type the answer as 1.5 because it's up to 1 decimal places. Okay, so then that's all from the mathematics subject. I hope you followed all the questions. Thank you all for joining this session. Thank you all. Bye.